Scale Talk, recording to and go. My talk is on Linux and its microcomputer predecessors pre-1996, also known as Why Linux. So before we continue, I really care about accuracy, and so I have a URL up here. In case you find any mistakes, you can go there and you can log and tell me how wrong I am. Yay! So, we also have some players, and this is a general talk. In case you haven't heard of any of these things, I'm just going to leave this up for a few seconds. I don't want to read over the slide. So here. All right, we'll move on to the second one. So the present, this is chapter 1. We always use Linux, but how did that happen? We use Linux even if we don't know it. Whenever you see a machine reboot at a grocery store or at an airport, it's like, oh, hey, there's that penguin again. Linux has arguably become the most ubiquitous operating system, but how did that happen? Well, a lot of reasons are given, but this is the one that you see the most of, is that there's a 21-year-old who posted to a news group, CompOS Minix, and saying, hey, I'm building a new operating system. And then everybody came through, and the rest is history. That sounds ridiculous. I don't think things happen like that. Essentially, it's saying a college kid with a hobby project set our computer revolution by posting. There's got to be more to it than that. There were many freest choices of Unix back then. In fact, there's a small timeline. So in '84, Purdue had one called XENU. You can see right here, GNU Herd was certainly working its way through over the years. You had BSD in 1989, and so there's a lot of other micros available, micro Unixes available at the time as well. Here's a timeline here. You can see commercial, you can see academic, and you can see free offerings up there. Also, there was Oberon by Pascal's progenitor Nicholas Wirth. It's from '87, and there are other minor ones I found references to in the back of magazines and long forgotten Usenet posts, and they didn't even make the slide deck. Here's various commercial efforts. Some of these are complete systems, others are just kernels, such as Mach. The point is, Linux wasn't shouting out from the wilderness. There was an active and vibrant Unix on the PC ecosystem, an underground that protected him substantially. And in this industry which hasn't had direct lasting impact. So products such as Xenix and Coherent were hot stuff at one time, and now only scholars and historians know about them, because this was the winner of the Unix war. Okay, how? This guy's pet project won not only in microcomputers, but also on all classes of computers. I was only able to find one commercial Unix still around, except for the special case of Apple. It was Xinuos UnixWare 7 Definitive 2018, which last release was actually in 2017. Looks like it can still be purchased, and that's it. It's deader than dial-up. People say, oh, hold on. There's more to it. What about the BSD lawsuit? That was a big deal back then, right? So they talked about this BSDI, 2-year night court drama, and a lawsuit with an organization called USL. But that doesn't make any sense either, because Linux was delayed 13 years by a bunch of SCO lawsuits, apparently, or Linux was held up. That should be changed. Linux was held up for 13 years by a bunch of SCO lawsuits, but it didn't really affect the progress of Linux in general. So let's just say held up. So remove held up. BSD has a history stretching back to the mid-'70s. The two relevant BSD names for our stories are husband and wife team Bill and Lynn Gillitz. And why didn't this win the theoretical US Unix war? This is usually the result given, but it doesn't make any sense. Besides, if we look at the BSD math here, Net1 BSD is from 89, Linux is from 91. What about the 2-year head start that they had? What about the 30 years between 84 and now? I personally believe BSD is clean, great, well-built, stable. If I was to teach a course on operating systems, I'd use the NetBSD kernel. I think it's quite excellent. But I'm not persuaded by the argument. BSD is much older, and in an interview with Bill Gillitz in 1994, he says he started working on 386 BSD when the 386 came out in 1986. if we took this at face value that there was a 2-year hold in BSC, then we should go over to, say, Usenet and see a fair amount of silence during that lawsuit period. But in fact, we did not. This is just a small snapshot of activity. It was lively and vibrant. Some of the authors had political statements in their SIGs against the lawsuit, but there's no evidence of any kind of type of chilling effect. The highlighted post right here is update on the USL lawsuit, amidst a bunch of articles talking about progress and bugs. I mapped out the velocity of 3 to 6 BSD Usenet articles and tried to see if there was any noticeable decrease or change in the velocity of activity correlated with the court case activity, and although I'm not a data scientist by any means, the two look completely unrelated. Lastly, there was a number of articles across Usenet with titles like Linux for 386 BSD, where people listed out the comparisons on which one they should choose, although many included minutiae such as specific hardware and protocols. None had any reference to the lawsuit or as a reason to choose one or the other. So I have to be forced to reject the hypothesis. It is often given, but there's no contemporaneous material evidence to support it. If you want to tell me how wrong I am, then go to URL and tear me up. I just want things to be accurate. Regardless, Linux has become at least an order of magnitude more prevalent than BSD. Why is that? The first theory here is from a 19th century. Let's do why is that. The first theory is a 19th century approach to history called the Great Man Theory, and the second is a latter 20th century approach called history from below, or often social history. So let's just go to the once in generation one. This one is rooted in social hierarchy, so it has a political variance to it that I find particularly offensive. But that's not the point I'm going to get into. I don't think it's useful. It says some great and glorious thing happened, but you can't do it because you don't have the right genes or whatever. And so I'm going to just not even look into that one. I'm going to look at the no superheroes required, which is the social history approach, using the power of syllogisms on the screen. So take that, Socrates. I like number 2. Whoops. One is a much shorter speech, of course. There's an 1841 book by Thomas Carlyle titled On Heroes, Hero Worships, and the Heroics of History. I'm not joking. It positing that great men should rule and that others should revere them, presenting a Horatio Alger story, and this would just be a fun biopic if I did that. However, we have a much harder task ahead of us, which is that of the social history. So, in order to do so, we have to start with hypotheses, and we have more terms. Again, I'm not going to read the slide. That's kind of rude. You can read it yourself. I'm just going to leave it up here. All right. So here is the thesis. And if the center will not hold, and if things fall apart, and if anarchy is loose upon the world, we might as well make it productive and get a nice operating system out of it. Maybe a free Unix needed. Hacker on Unix underground culture. The increased power of microcomputers, so wide availability of the internet. Something not legally problematic. We're going to go over each one of these. And that's a big maybe. There's also maybe not that are often presented as reasons. And so this is more dispelling. Here's some common claims. The first one is that Unix was thought to be too complicated. Not really. When talking about elegance of Unix, there are mentions of how it was only about 10,000 lines of code, created mostly by 2 people. Even 386 BSD 20 years later was done by the Jolitz, a husband and wife team, as we mentioned beforehand. Then you have the anarchist models were thought to be impossible. There's many predecessors to that. That's not true at all. And so we have to go into the pretext. This is the ancient history. The first one is the Unix, and we need to do that. We need to move those things up. Okay. So there's basically 4 principles in the 1974 original Unix paper. Let me put that in here. Hold on. Okay. Write more. And I distilled it down to leverage and don't invent things. So try to use what existing resources you have in front of you as opposed to doing it invented here. Focus on needs and not desires. Your real problems as opposed to ones that you theoretically might have later on. Doing beats planning. So get something out the door quickly as opposed to trying to do something all great and magical. And use early and use often. These things may not be the best ideas always, but together they form what you can call a synergy, if you will. That's what I want to do. They form a synergy. And yeah, so that's that's what I need to do is a transition to make expensive things cheap. All right. Night 2 is not as polished. That's fine. I'm glad I'm doing this. All right. So when we're looking at computer laws here, basically the idea is that as technology progressed, you wanted some of the mainframe features on the mini computers, and with Linux, you wanted some of the workstation stuff on the microcomputers. You look at the costs over here; these are order of magnitude costs. That's essentially one of the underlying hypotheses of why you're going to do this. One of the interesting things is that as this transition goes right from here to here, it's actually this is what I'd call the hacker or the difficult space. I have another sort of chart that I want to put up here, but I don't know how to fit it in yet. Anyway, while we're looking at, let's, all right. So I'm going to quote something called Bell's Law from 1972 about how roughly every decade a new lower-priced computer class forms based on a new programming platform, network, and interface, resulting in a new usage and establishment of a new industry. So you can see right here, this is roughly about yeah. Anyway, as mini computers came on the market and became more powerful, Unix was there to leverage the increasing capabilities of machines. But like explorers, the people who got there early didn't have it easy. So we have to. Is that what I did? Yes, but that's So here's an example of as you go along the Bell's Law, you're going from mainframes to minis to workstations to micros. So the whole point is that the velocity of the graph or the acceleration of the graphics needs and all these different needs down here, they accelerated at a much slower rate than the technology underlying it. This can be embodied in Grosh's law, which held more through the 60s and 80s that computer performance increases the square root of the cost. And when you combine that with the more common Moore's law of the 80s and 90s, that transistors per chip double every 18 months, then you could see how the industry would eventually eat itself through multi-decade-long digestion. However, when new things come in, they come in unpolished. That needs to go down here. So we have what Unix was about, version 2. Essentially, it said, given right here, it said it was a hacker's tool. And as a hacker's tool, it meant that you're basically on your own. Hey, isn't that fun? So there's no advertising, there's no support, no bug fixes. You have to pay in advance. It's like here you are, like a dark alleyway. Here's something called Unix. Have a good time with it. And you can also see it's okay because some of us are crazy and prefer it that way. Or you can also see Linus Benedict Torvald saying the same idea in October 5th, 1991. He says, you also need to be something of a hacker to set it up. So for those hoping for an alternative to Minix 386, please ignore me. It is currently meant for hackers interested in operating systems and 386s with access to Minix. And in it, he maintains focus on the hacker as the initial basis. And when you maintain focus, you have to intentionally ignore. And he says ignoring in there. And I wish it was nicer, but that's just how you have to start things. And because you had to have to know what you were doing, it meant, because you have to know what you're doing, it meant that it was initially introduced through engineering and technical people and not through sales channels. But this worked. And so it came from a bottom-up kind of way, as social history would sort of say. But eventually it led to some problems. So after it became successful, it looks like they won, but not so fast. A bunch of corporations came in, and they had their own idea of pricing and whatever. And there's all this kind of market competition, and they wanted to differentiate themselves, and so they had incompatibilities. Not only that, but But after Unix went out there, being ported to a bunch of things, as you saw, it was going from mainframe down to mini computers. The first port was actually back up to the mainframes, so it kind of blossomed outward. And there were these two organizations, Unix International and Open Software Foundation. Unix International was a coalition between AT&T and Sun and a number of other Unix vendors, which are listed here. Thought that would lock them out of the market, so they actually started something called the OSF. They came up with an it was a big mess. So that was not great. But also the microcomputer revolution, which started in the 1970s, also kind of became a big mess. This is a quote by Franz Kafka. I should put that in there. Quote is by Kafka. In 1985, in fact, Microsoft argued that Xenix would be a multi-user version of DOS, and Ballmer in 1987 said they didn't see it competing with their plans for OS/2. This is early. It was at that time seen as successful Windows 1.0. Windows 2.0 then got released in December. It's a complicated history. But in 1985, Microsoft was quoted as saying there was over 100,000 Xenix installations. At that time, it required 360K floppy disks, which was seen as a huge burden. Putting that in perspective, in case you're young, I just put that in there. A 32 gigabyte $5 micro SD card is about 93,000 floppies. That's 190 meters long, stacked end to end. It's like a 2.5 minute walk to just walk past all of them. All that storage is now in the size of your thumbnail and costs an unnoticeable amount. Turns out software distribution used to suck. Here is some ways that it used to be done. Speaking of Microsoft, that punch tape is how they distributed BASIC for the Altair in the 1970s. Paul Allen made a loader as he flew to MITS to demo it by using a hole puncher on the punch tape on the plane. He had no idea if any of it was going to work, since even their BASIC had been written on an emulator he and Bill made by reading some manuals. It took about 20 minutes to load the tape when he got there, and of course it wasn't stored on disk because that computer didn't have one. Just keep the computer on, I guess, if you want to use the software. As I said, software distribution used to suck. So there are many ways of doing it, and some of them are more accessible than others. So you had retail, and retail was much more accessible than mail order, which is more accessible than getting stuff from your friends. In the 80s, that was more accessible than a dial-up or internet, which was actually hard to get access to. Only academics or researchers really had that in the 80s. And as your number of units out that you are producing, the cost of these went down. And so if I was producing, let's say, I don't know, 1 million of something, then retail became really cheap. So there's a quoting Marketing High Technologies. This is from Bill Davidow. This is 1986. It says, "It's not a product without a distribution channel, or in Linux's case, a distribution. The device may have the potential to use... if I have the device in here, which is what he uses as something that's not a product, let's just call it the technology. The technology may have the potential to address the needs of many, but without specialist redistributors to put it in the hands of those customers, it will not succeed. Products are sold through distribution and not to distribution." So all of these are the ways that it gets in. But because these costs are so high, there were non-retail models that were being used. We had freeware, shareware, public domain. This is where public domain has to be. So maybe insert public domain. Insert public domain. Public domain side. All right. So the thing that is unsolved by this is actually this is the distribution of software, but it says nothing about edits and updates, which are equally important. So, oh, I had changed it. I changed the order. All right. So what the fuck, mouse? Come on. Why is it down there? All right. So let's go to Minix. Here is Minix relied on the constant holding in that I had in the previous slide. Here he explicitly says they are not public domain, which is why I should have a public domain slide in between this. However, the publisher did not object to people making a limited number of copies as a sneakernet for your friends, etc. If you want to sell it, you need permission. That's another kind of distribution. In the book, you will find a postcard that you can use to order the software. That's mail order. I don't want to spend the next 5 years duplicating floppies. He's talking about how difficult it is in order to do sneakernet or friend distribution and like that. One of the problems of Minix, or the core problems, I need to align those things too, is that Prentice Hall wanted to sell textbooks, Tannenbaum wanted to teach classes, and that made Minix a poor tool for the software revolution. Let me write it in here, align boxes. Cool. Make it bold so I know what to do it. GNU also had these problems, and if you look at here, it says the easiest way to get a copy of GNU software is from someone else who has it. That's Sneakernet. If you have access to the internet, you can get the latest. We talked about that. You can order one, consult the company order form for prices and details, because you still have to pay for it, as it says down here. Free doesn't mean free like that. But because it was still in the 80s and people hadn't really thought about the implications of the internet, people hadn't thought about the implications of the internet. Everything was still a top-down hierarchy. And so the empowering copyleft through the network effects hadn't been realized. And at this point, I should have already introduced copyleft. That's what the public domain thing is about. Right. All right, so software updates. This is the problem. When most computers, so there's a lot of software update complexity because, oh, that doesn't make any sense. All right, rewrite. So if you wanted to roll out software updates, if you are the author of it or the original distributor, if you were to do these different kinds of distribution channels, it was equivalent or maybe a bit harder if you're trying to do it, by Sneakernet, because you don't know exactly where it went. But if you're, let's say, somebody who forked it or somebody who and you wanted to do an update, let's say Lotus 123 through retail, that's not going to happen. But if you wanted to do some kind of update upstream, let's say over the internet of an open source product, that is almost as easy as if the author had put it out something themselves. So here's the different distribution channels and how software can be developed in different ways. And so Linus Benedict Torvalds also wrote this. Linus Torvalds also talked about this on his October 5th, 1991 post. He said that he's enjoyed doing it, and somebody might enjoy looking at it and even modifying it for their own needs. It's still small enough to understand, use, and modify, and I'm looking forward to any comments you might have. Let's just drop that one out. I'll leave it in. I'm also interested in hearing from anybody who has written any of the utilities, libraries, functions for Minix. If your efforts are freely distributable under copyright or even public domain, I'd like to hear from you so I can add them to the system. So here he is talking about the internet way of doing things. All right. So politics. This is about the complexity of building software. It's not about electing people. Beforehand, when we were talking about the 1974 Unix paper, we had an idea of needs, not desires. This is a little graph of what this means. And so essentially, in any software product or idea, you've got bugs, needs, desires, and aspirations. And you can break them up into known, agreed, and demonstrable. So bugs can be known. I can agree that the bug is in front of me, and I can demonstrate it for you. Aspirations is not really, I can sort of have an idea of what I want to have, and maybe somebody has a different idea of what that means, and if I can no, it's hard. So, for instance, let's take Raj Reddy from Carnegie Mellon University. In the early 80s, he talked about a theoretical 3M computer, which was a megabyte of memory, a megapixel display, and 1 million instructions per second, and under what's called a megapenny, or $10,000. And that was seen as a minimal workstation. There's no detail for how to get there, and it took a few years, as you can see out here. But these days, the lousy smartphone hits those numbers. But 40 years, that's like 100. That's like 1,000 sprints. So it's a problem. So this is about the politics. Focus is about ignoring. It's about the politics of that. And how do I transition to here? It's not desires. This doesn't transition right. Transition needed. Cool. All right. Let's just pretend a transition happened, or I have this in the right place. You may have heard that commercial software began with Bill Gates' open letter to hobbyists and hobbyist computers in our hobbyist computer in 1976. Computer hobbyists. Where he denounced SneakerNet distribution because he didn't get paid for each of the copies. SneakerNet distribution of Altair Basic actually is the thing. That's not really where commercial software begins. Initially, software was in-house, coupled with hardware or contract-based. The shrink-wrap version of retail software, popular in the 1980s, began really in 1968 when the hardware vendors agreed to decoupling the software and birthing the vendor-supplied software catalog. And this decoupling is probably what made Unix success possible. Here's an ad from 1959 looking for a computer programmer. And here it is after the decoupling. You can see that sales of proprietary software forecast is 1969. So commercial software was alive and well in the 1960s, and it did not start with the letter by Bill Gates. But the problem is that this led to a lot of legal complications with Unix. Here is a little snapshot of various Unixes. It's very complicated. And each of these has different terms about who can use it, who can share it, who can sell it, how much. You can, if you had, Magical Eyes, you could see BSD in here, which is open source. You had closed source solutions. You had ones that had different terms of suitability, who could get copied to, blah, 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 what kind of systems. It was very, very complicated. And you'd need to have legal counsel if you wanted to, especially if you wanted to update or change anything. It's nuts. And so there's another thing is that we could maybe do clean room design. That's what Net1 tried to do with 386 BSD. And they said, and even though they had cleaned it out with 386 BSD, they still went to court over it. So clean room design didn't really do what was necessary. But GNU proposed a solution to all of those problems. And it wasn't about public domain because it was something called copyleft. And this is something... Should that go in a different place? No, leave it here. I can talk about it twice. Sorry. And because of that, actually, I should move it up. And then that should become a public domain. So, yeah, sure. So this one, 2.1 should become, where did I go? All right. This can become the public domain slide. Cool. All right. So we're gonna go over here. We also removed that, so I don't have to worry about that. Okay. So and then I can update this because I don't like this. I don't like profanity up here. The software evolution, basically. I'm sorry. I'm just joking. Can I pause? I can't really. I just have to work my way through this. Linux history is very online, and because of that, it probably meant that there were no legal hassles or confusion because the license was laid out in 0.96, and it made things clearer and no longer complicated potentially. You could say that before social media, there was social software. And so now we're going to get into the price. Price is. And this is plural for a reason. You'll find out why. The first one is that everything was too expensive. This is part two. I found an article here about low-price workstations from Sun, talking about $6,700 workstations. But if you compare it to the $699 386 that came from June versus May of 1990, you can see this is far cheaper than the Sun over here. So in the 386 brought workstation-like features to a desktop price. And there's a debatably humorous adage about this concerning Andy Grove and Bill Gates. What Andy giveth, Bill taketh away. In this case, new software was Linux, and it was consuming the increase in capabilities provided by 386. But that's not the only kind of price there is. But that's not the only kind of price there is. There's also the price of time. And people say, oh yeah, Linux is free only if your time is worthless. Well, maybe not. So here, essentially what it is that as your problems become more specific, you have to have more specialties, and the tool has to be more specific in order to address those. And there's a system design limit. And so Windows might actually be really easy to install and get going, but you hit a wall at a certain level of specificity. 386 BSD and the BSD derivatives might be more complicated to install, but you end up getting this part, and then because there aren't a lot of people involved in it, and a lot of them were much older in their careers and are more expensive, the cost went up substantially. Linux is a bit cheaper, and their curve went up a little bit more gradually. That's because they were able to lower the cost of specific problems by changing the I to we, because there were more people using it. You can access the right people's time because there are more people that were developing it. Linux had a more hackable system than 386 BSD because it was shittier to begin with, to be honest with you. And the experts were cheaper because they were basically all students. The computer scientist Calvin Moores spoke to this in 1959. The more difficult and time-consuming it is for a customer to use an information system, the less likely it is that he will use an information system. So as the complexity of the problems become more intractable, the approachability of the lower levels and internals of a system become increasingly important. This is also embodied in Zipf's law of least effort. And the next thing that we want to talk about is prosumer software. And I want to actually add the Turing tar pit to here. All right, add Turing tar pit. So, prosumer is a modern idea of a producer and a consumer put together. It is often used for social media where you're consuming other people's other consumers' productions. Essentially what Linux was able to... That should go to the next one. And actually go to the next one. Cool. So, essentially what happens is that you have this idea of product solution and integration forming this engine of production. And so let's say you had, I don't know, any 2000 network card, and nobody had support for it yet. Well, somebody made a solution for it, then it got integrated back into the kernel, so then people who have any 2000 can now use it. And because you had this kind of Ouroboros style development, this made it able to get to new users who had fewer problems and different hardware much easier. And it helped it get from a toy to a tool. As the value was created, the product fit better. By recruiting new troops, Linux was able to exploit Reed's law. This is from 2001. The utility of large networks can scale exponentially with the size of the networks. The number of combinatorial subgroup participants from these larger collections grow more rapidly than the original utility of the groups that joined. So essentially, if me and my friend decided to use Linux, then all of a sudden my friend will meet somebody else, and then that will create a new type of subgroup that wasn't possible beforehand, and then I might meet somebody else that has, I don't know, an NE2000 card. So here, what we're trying to do is we're trying to say, yeah, the Turing tar pit should be above. Ooh, that's a much better match. Fantastic. All right, so essentially here we are saying that you have to start on a hobby or entertainment and education in order to get those people into the coalition. Those are people that are very forgiving of problems. But then once you get those, then you can get to the productivity and personal, business, professional, and critical infrastructure. So you can go up there. 386 BSD, I argue, try to skip it. If you look at this chart down here, I analyzed about 2.5 million Usenet posts, and you could see, first of all, the defense of this chart over time. The edu went down, the com went up, but then it turns out that the edu of Linux was always higher than and the com of 386 BSD was always a bit higher. That defends this one over here. Essentially, you can have this as a Linuxist revolutionary theory from Lenin, if you will. The hacker vanguard empowers the personal computer proletariat, which gets the business-oriented bourgeoisie, and then the prohibitively assiduous aristocracy, which is up here at the critical infrastructure level. So the other thing that so a transition needs to be done. Fantastic. Transition to actually, I think it was done. So how do you get from toy to tool? And you can do that by making expensive things cheap. Now we are going to define effort as one more thing. Money, not only plus time, but also now plus expertise. And these alphas or in beta and gamma depend on what you're talking about. We're going to go over what these different arrows are in a few seconds, but we're going to have something called utility function. It's roughly software capability divided by effort demanded. And sometimes they both increase over time. Blender, for instance, is highly capable software, but also takes a lot of expertise to use effectively. Many mobile and web apps, on the other hand, actually remove power user features over time and make the product require less effort, while also making it less capable. And so at that point, the effort demanded goes down, and software capabilities also goes down. Still, other software, APIs and frameworks come to mind, can have the Fred Brooks second system smell, which is that they have a new version that's far more difficult to use and leads to inferior results. And so then actually the effort goes up, but the software capabilities goes down. And I'm not going to give any examples of those grisly monstrosities. But we're going to talk about the multiple arrows. In order to get a larger user base, you need a diversity of capabilities requiring a diversity of efforts. Linux was able to achieve this by outsourcing the actual packaging of the OS through distributions. There's something called the... Yeah, I need to write something about that. Write something about this, yeah. So Eric S. Raymond introduced the idea of the cathedral and bazaar, saying that Linux was developed through this bazaar method. And essentially, it was a horizontally stacked. And so here, if you will, as opposed to Windows, which is Microsoft is doing all of these things, or maybe the drivers are not by Microsoft, but let's do Apple. Okay, so Apple's doing all of these things. Let's use Apple as an example. Because Apple is vertical. So Linux is able to break this up into these horizontals. And so we have distributions, which you've heard of. But then in order to get the software, there's many options now. You can do it through apps or pip if you're using Python. There's Snap, ABS if you're in Arch. There's Flatpak. There's all these different binary distributions. And then down there, there's many organizations that produce these. There's many ways of customizing it. For instance, Android is a fork of it. You have make config. You can make your own kernels. You can do different kinds of modules. And so as over time the category divided to become more categories, it meant that you had more on-ramps and product market fits than the alternative. So you're able to meet all of these points, and then you had many different levels of software capabilities, many levels of effort demanded in order to get onto it. So as a result, you had this victorious anarchy. By separating distribution support, customization, and ancillary software, all these strategies happen simultaneously. So harking back to how we had different needs and different kinds of computer types over time. Over time here you have different strategies. You can either stay with the customers or you can go upstream. Linux was able to do all of those things at once because of the horizontal design. It was able to do this via the packets. So we're going to look at a little bit more about the horizontal design. This is Andy Grove from Only the Paranoid Survive. He was talking about this as far as the computer market went. So initially you had these vertical stacks wherein one company controlled them all, And then in the mid 90s, you had I don't know, sales and distributions, application software, computers, chips, all these different manufacturers doing different parts of it. The problem is that over time, this led to hell. And so Windows decided to say, we can't do that. We're going to be the standard, so other people are going to actually develop software and then make it compatible with Windows. OS2 was unable to compete, so they just died. Apple said, well, let's just go vertical. Let's just be all in-house. And then Linux said, well, we can maybe do this if we can get free labor somehow. And so then it could just, eat up all of these things. Come on, scroll. So the only way that Linux could get free labor is with if it had a lot of people. So there's something called the Eternal September. Essentially, it's a posting from 1983. I need to do an introduction to that. So define the Eternal September. Let me just give it essentially, when the internet was all academic, every September a bunch of new people came on, and they had to be taught something called netiquette. And so the internet would then grow basically, every September. And then in 1983, because of dial-up ISPs and people were able to access the internet through AOL or Prodigy or CompuServe or all these other services out there, then they called it the Eternal September, where basically there's always going to be an influx of new users. But in order for that to happen, you had to be able to run ISPs cheaply, you had to be able to run web servers cheaply, and then have a networking effect of those people coming on board that improves the quality to make the other things cheaper. This is another benefactor of the Eternal September is attributed to Linus's law, which is given enough eyeballs, all bugs are shallow. And there's empirical evidence that this is a tendency rather than absolute, but we can just go on. Actually, I don't need to do that, and then don't need to say it's by Eric S. Raymond. So, in order to... But let's look at the various eyeballs. Let's look at the various eyeballs. So this is Linux's non-Linux contributors. As far as I know, on Comp OS Minix, the initial code was released in October of 1991, and the initial sort of first person to make a contribution was Linus's college friend, Wozniak. And then next month, there was somebody across the channel. This is Theodore So. He, from MIT, made a contribution. And also that month, someone from University of Utah made one, Galen Hunt. And then Drew Eckhart, Colorado at Boulder, did that. And so as he was releasing it, he got a bunch of students and people from academic, young people, in order to do a bunch of contributions. And this was happening when the host count doubled to 1 million. The backbone went to what is now seen as pretty slow, but at that point it was quite fast. The commercial ban on websites were lifted. You had the www, the Mosaic. This all came around that time. And by the end of 1992, then you had people coming online. The internet was doubling at about a 3-month clip. And so you needed a quick and dirty solution very quickly. And the only one that was able to do it was really Linux. So here's a number of things around 1992 that you could possibly use. In 93, NetBSD, yeah, sure. And Minix, not really, because it wasn't cooperatively made. It didn't have a complete operating system with all of the nice things that you're looking for, and it wasn't no cost. Net2, it's questionable because lawsuits and all these other things like that. It still wasn't cooperatively done. Along 386 BSD, it was done by the Jolitzes. So it didn't have that kind of, this lower level free development that you could see that rolled the thing uphill from the turning tar pit. While Linux was arguably maybe not complete, that's where the distribution thing came in. So, this meant that over the past, I have to do it up here. Over the past 30 years, Linux has become the only reasonable option for all of these things. So we go back to this thing beforehand. Windows basically says your move. It's your job to actually do this. Mac says, like, can we do it vertically? And Linux just eats them all up. So cars, phones, spaceships, toasters, robots, whatever. Here's supercomputer operating system since 1995. Here's an interesting thing that Linus actually said. He said he thought the timing was good, but just a year earlier, he didn't think it could have been done, and a year later, somebody else would have done something similar. So yeah, that gels with what we were talking about beforehand. So yeah, let's go to the perhaps. So what can we learn from all this? The first is, did we just define luck a user's manual? Did we talk about how to feature? Can we actually apply this? Let's look at something called Crossing the Chasm. This is a famous book by Geoffrey Moore, put out in 1991, and this was for commercial software. He was talking about how you have these innovators, early adopters, early majorities, late majorities, and laggards, and then you have this thing called a chasm right here. Essentially what happens, you have all these people who are enthusiastic about the product, but then the product isn't really good enough to get people that are pragmatic about it. And so getting it over this gap right here. Here's an example, electric cars, for instance. You have enthusiastic people that have electric cars, but people argue that it's not quite pragmatic yet. They say, well, it doesn't charge fast enough, and they're too expensive, and they make all of these pragmatic arguments against it. And the sales actually went down for a bit, and they'll probably eventually just go back up. This actually happened with broadband. It happened with cell phones. This is how new technology happens. So there's something, but this is a commercial product. So let's look at how this might actually progress into the open source world. So I'm going to say something called Crossing the Open Source Chasm. And we're going to talk about how initially you have passionate people like Linus Torvalds or Richard Stallman, but their passion can be exhausted. So you have to have enthusiastic supporters, a networking effect. And then you might have a chasm where the product just isn't good enough yet for the pragmatists. And so basically you need to have that kind of circular momentum in order to get it forward, so the pragmatists say, yes, we can use it now. And then the business people get on board and say, oh, actually, we can use that as well now. And then eventually the enemies, so Microsoft is now, has GitHub and is kind of pro Linux. And so this is how you get to the end. And we're doing some poetry. But the problem is that although this is super clean, this isn't how reality is. Reality is super messy, actually. As you can see right here, it's ugly, confusing, and it's illegible. You really don't know whether you really can't map these things onto real events that have happened. It's really tough. And so does this mean that you can conclude anything? Well, not really. We can choose stories, perhaps, which have the strongest of evidence, and hopefully we can do better than bullshit. So we're going to make a few little posits here. Maybe vision plus failure equals success, perhaps. So strong visions and not strong protections. GNU Hurd led to Linux. Maybe Minix led to Linux. You could say these types of things, this openness led to that. Ted Nelson of Xanadu led to the World Wide Web. Xerox Alto led to the modern desktop. So here's a couple examples of that. So perhaps strong IP enforcement on strong visions diminishes the chances of success, and you must let go of that which you love the most. Maybe. Here's the second one. The right pushy wins. And the idea is that if you're working on something right now, that you are in that first part of the chasm. First part of the graph, and you haven't crossed the first chasm yet. You're in the second one, and so you're way early, and you have to be aggressive, as in you have to be passionate, enthusiastic about whatever it is that you believe in, and you also need to be committed to others because you need those other people on board in order to get across the chasm when you approach there. It's really important. So whatever you're doing, it's going to take years, and it's going to manifest differently than what you thought. You have to let ideas grow on their own, and you have to love the ideas, but you have to avoid your codependency upon them. So next steps. You can say, do one thing and do it well. You can work together. Handle text streams because that's the universal interface. This is actually the Unix philosophy by Peter Sallis. And it's somewhat a joke and somewhat not. Let me quote Tracy Goddard from Soul of a New Machine. Looking into the VAX, West had imagined he saw a diagram of DEC's corporate organization. He felt that VAX was too complicated. He did not like it. For instance, the system by which various parts of the machine communicated with each other. There was too much protocol involved. He decided that VAX embodies flaws in DEC's corporate organization. The machine expressed that phenomenally successful company's conscious bureaucratic style. Essentially, we shape the buildings and thereafter they shape us. And so when you look at these Unix philosophies, that's also a philosophy of how you can organize projects. And so, you should, for instance, you need to work well together. You should do one thing. You should do it well, and you should definitely handle text streams. You can communicate with each other. So you can use the Unix philosophy in how you interact with humans. Where did I miss that? Oh, yes. And here's another version of the Unix philosophy. This was by Ritchie and Thompson. You know that. Make it easy to write, test, and run programs. Again, think about this as far as humans go. Interactive use instead of batch processing. And so, try to do things quickly and have a tight feedback cycle. Economy, elegance of design due to science constraints. So don't try to go too ambitious. Make sure that you use what you have in front of you and create self-supporting systems. You have to support each other and make sure that you can move to the next step and, be human about it. You can go to Melvin Conway's 1967 law for this. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Eric S. Raymond paraphrased this as, if you have 4 groups working a compiler, you'll get a 4-pass compiler. And then perhaps last, we said yesterday to create a better tomorrow, and the future is ours to make. Probably. That's 51 minutes. That's not bad. All right, let's stop.